Good day, students. Welcome to class once again. The last time we talked about the laws of chemical combination, and we were able to verify about 2 of them. So right now we'll be talking about chemical combination. Now, chemical combination has to do with the ways in which your compounds are being formed, the kind of bond that exists between these compounds. So basically, we have about 4 types of chemical combination. We have the electrovalent bonding, which is the ionic bonding. Then we have the covalent bonding. We have the coordinate covalent bonding and the metallic bonding. Although we have some other intermolecular forces like your Van der Waals forces, the dipole-dipole force, and the hydrogen bond. So basically, we'll be discussing the major bonds. Okay, and I'll be starting with the electrovalent bonding. Starting with the electrovalent bonding. Now, this is also the ionic bonding. So at times when students are being asked about electrovalent bonding, we are also referring to the ionic bonding. Now, the electrovalent bonding is the transfer of electron from a metallic atom to a non-metallic atom. It's a total giveaway. And what this means is that there must be an atom that is willing to give out, and there must be an atom that is actually willing to collect. So most times the electrovalent bond happens between the metals and the non-metals. So I'll be doing some examples. Then we have some basic qualities, some basic characteristics of the electrovalent compound. They have high melting point. They are good conductors of electricity. They dissolve in polar solvent, which is water. Okay, so I'll be showing us the kind of bond that exists between sodium and chlorine. Yes, so I would like to break it into the key element shell. The sodium is 11, my chlorine is what? 17. So if I do 2, 8, 1, my chlorine is 2, 7, 2, 8, 7. So chlorine needs how many electrons to complete the octet structure? Just 1. And sodium here with 2, 8, sodium will attain stability as well. So sodium will be willing to give out this to chlorine. So at the end of the day, when the transfer of electron is done, the chlorine becomes positive and you have 2, 8. Then the chlorine becomes negative and you have what? 2, 8, 8. Okay, let me show us another one between calcium and fluorine. Yes, between calcium and fluorine. Yes, calcium is 20 and calcium is 2, 8, 8, 2. So calcium will be willing to give out these 2 electrons. Then fluorine is 9. You have 2, 7. So fluorine needs how many electrons to complete the octet structure? Just 1. But calcium is willing to give out 2. So what's going to happen here is that I'm going to produce another atom of chlorine, so that the 2 electrons from calcium will be shared 1, 1, 1, 1 between the 2 fluorine atoms. Okay, so here our sodium chloride is being formed. Yes. So therefore, the calcium and the fluorine, calcium is willing to give out 2 electrons, as I rightly said earlier. So when the transfer is done, you have 2, 8, 8 for the calcium. It will become 2 plus. Then the fluorine, the 2 of them will become minus. So that is how my what? Calcium fluoride is being formed. I have 2 here because I have 2 atoms of the fluorine. Okay, so that is all about the electrovalent bond, because it's a total giveaway. The metal is willing to give out electrons and the non-metal is willing to collect. But now moving to the covalent bond. Moving to the covalent bond, here there is no transfer of electron. We only share electrons here. And this is what happens. I cannot give you, you can't give me. Let's come together and form a relationship. So that is where the co covalent, like a company, let's come together and do something together. And that is where you have formation of some of our molecules, like your chlorine molecule, your hydrogen, my water, my ammonium, my ammonia. Yes, and I'm going to show us how these bonds are being formed. Okay, so for chlorine, chlorine is 287. Okay, so I have 2 atoms of the chlorine, 287 chlorine. Okay, so I'm going to draw the shells. In this situation now, this is the nucleus. I'll draw the shells for us to see. Okay, this second shell has 8. Then the last shell has what? 7. So we'll see what will happen now. This is the last shell. Now the last shell is going to bond together. Yes, because that's where you have the valence electrons. So 2, 8, 7. Okay, so 2, 8, 7. So the 7 for the last shell, now 2, another 2, making 4, making 6. Now the last one, that is the 7th electron, I'll put it here. So this is what they are sharing together, and that is how our Cl2 is being formed. Yes. Okay, the same idea, you can actually use it for the hydrogen ion, for the hydrogen molecule, sorry. Then you can also do it for water, but let me show us how ammonia will be formed. Yes, now for ammonia, hydrogen will be working towards getting a duplex structure. You know, hydrogen is just 1, and it needs 1 electron to complete the duplex structure, because in the first shell it needs just maximum number of electrons of what? 2 electrons. Okay, so the nitrogen is going to serve like a central atom. Yes, so nitrogen have NH3. So what it means is that I have 1 atom of nitrogen and 3 atoms of hydrogen. So my nitrogen will be at the middle, then the hydrogen atoms is going to surround it. And my nitrogen is 2 what? 2, 5. Because my nitrogen is 7 and my hydrogen is 1. So let me first draw for the nitrogen at the middle. So you have something like this, 2 and 5. So this is 2. Then the remaining 3 electrons, I'm going to split them, because it's the remaining 3 electrons that the hydrogen is going to attach to. And you know that each of the hydrogen will be coming with one electron. So look at my hydrogen coming with 1 electron. Okay, another hydrogen coming with 1 electron. You can see how the bonding is taking place. Another hydrogen coming with 1 electron. So that is how my ammonia is being formed. So there is sharing of electrons. So, and for our covalent bonds, they are not conductors of heat or electricity, and they are not soluble in polar solvent. So please do more examples. Just use the hydrogen molecule and the water molecule as your classwork, and drop it in the comment section if you are able to do it well. All right, see you some other time. When we meet next time, we'll be going to other aspects of chemistry. Thank you. God bless you.